Okay, so here in this video we have a typical parabola concave down bounded by the x-axis in the first quadrant. And what we're doing in the video here is revolving one rectangle about the y-axis. Now if you notice, the rectangle is parallel to the axis of rotation. And when we revolve it about the axis of rotation, when it's parallel, we get a cylindrical shell, we call it, because there is a hole there in the middle. So this is what the shape is looking like when we take all those rectangles and revolve it about the axis of rotation, again, which is parallel. And that's the shape we end up with when we take that area right there in the first quadrant, bounded by the x-axis. And again, we take one rectangle parallel to the axis of rotation, and there's the result, one cylindrical shell. So the question is, what's the volume of that cylindrical shell? Because we know if we can find the volume of one of those shells, then we can find the sum of all those volumes by taking the definite integral from a to b. So what is the volume of one of those shells? Well, if you think about it, what you have here, if you were to take one of those shells and break it apart, what you end up with is a rectangular prism. And the length would be the circumference of a circle, 2 pi r. So I'll wait for it to get caught up here. Okay, so there's the rectangle, parallel to the axis of rotation and being revolved about the y-axis. So the length of that would be 2 pi r. This would be right here the height, and your thickness would be dx. How thick it is, right here, that would be dx. So the volume by shell is 2 pi times the radius, but the radius, notice, of the shell is the distance to the axis of rotation, times the height of the rectangle, and of course then times dx for the thickness. The change in the x's would be the thickness. So that is how we would come up with the volume by shell. It is again 2 pi times r, but what is the radius? The radius is the distance to the axis of rotation. So when it comes up again, if I take this one cylindrical shell right here, the distance to the axis of rotation is the shell. The distance to the axis of rotation, I meant, is the radius. This right here is your dx, and this right here is your height. It's the same thing as if you took a rectangular prism, like a roll of paper towels, and sliced it and folded it out, on a flat surface. The distance around is 2 pi r, that would be the length, times the height, and the thickness would be your dx. And this gives you a nice, good visual of what the shape would look like when you revolve that area about the y-axis. The next video we'll talk about how to use the volume formula by shell.